This video will summarize the operating principles of a 4-stroke cycle piston engine. It will explain the interaction of basic engine components using live-action video and computer animation. An engine is a source of power for propelling a vehicle and operating other systems. Termed power plant, it burns a fuel inside its cylinders, usually gasoline or diesel oil, to produce heat, expansion of gases, pressure, and resulting part movement. Since a piston engine burns its fuel inside itself, it is termed an internal combustion engine. As you will learn, the arrangement of parts of the engine allow it to harness the energy of the burning fuel very dependably and efficiently. The engine is usually located in the front portion of the car body. Placing the heavy engine in this position makes the vehicle safer in the event of a head-on collision. The engine block is the framework or backbone of an engine. Other major components fasten to the block. Accessory components also bolt to the outside of the block. The cylinder block on this engine is painted black. Note the other components fasten to the block. A cylinder is a hole machined down through the top of the engine block. The cylinder holds the piston. The cylinder head bolts to the top of the block. The oil pan bolts to the bottom of the block. The crankcase is a lower area in the cylinder block. The crankshaft mounts inside the crankcase. Main caps fasten to the bottom of the block to hold the crankshaft in place. The piston converts the pressure of the burning fuel or combustion into movement. It transfers the pressure of the burning fuel to the piston pin, connecting rod, and crankshaft. The piston slides up and down in the cylinder block bore. The piston produces a reciprocating or up and down motion as it slides in its cylinder. The piston rings produce a seal against the cylinder wall. The two top piston rings are called the compression rings. The lower ring is called the oil ring. The rings fit into grooves machined in the piston. During combustion, the compression rings must seal the tremendous pressure produced by the burning fuel. The rings prevent cylinder pressure from leaking into the crankcase. Without compression rings, an engine would not run or would lack power. The oil ring, also called a scraper ring, must remove excess oil from the sides of the cylinder wall. As the piston slides down, it squeegees off oil and returns it to the crankcase. Without an oil ring, oil could enter the combustion chamber and be burned. This would cause the engine to produce blue smoke. The piston pin, or wrist pin, slides into a hole machined in the side of the piston. It is a case-hardened, hollow steel pin. The pin fits into the piston at very close tolerance. The distance between the hole and the pin is measured in thousandths of an inch. The connecting rod links the piston pin and piston with the crankshaft. The rods are exposed to tons of force and are usually made of cast iron, stronger forged steel, or even expensive titanium. The connecting rod swings back and forth as the piston slides up and down while the crankshaft rotates. The rod's small end has a hole machined in it for the wrist pin. The wrist pin attaches the connecting rod to the piston. The big end of the rod fits around the crankshaft. The rod cap bolts to the body of the rod. High tensile strength rod bolts connect the rod cap to the rod body. A rod bearing fits into the rod body, and another rod bearing fits into the rod cap. The rod bearing provides a friction surface between the rod and the crankshaft. The clearance between the rod bearing and the crankshaft is about 2 to 3 thousandths of an inch, about the thickness of a human hair. The crankshaft converts the up and down motion of the piston into a rotary motion. This allows the engine to harness the power produced by the burning fuel and the moving pistons. The crankshaft is usually made of cast iron, but it can sometimes be made of stronger forged steel in high-performance engines. As this engine cutaway shows, the crankshaft mounts in the lower area of the block. The crankshaft mounts on main bearings, similar to the rod bearings. The main journal of the crank rides on the main bearings. This allows the crankshaft to spin freely. The main journal of the crank remains stationary, while the rod journal rotates around with the connecting rod. The crankshaft transfers power to the transmission and the drivetrain. A flange on the rear of the crankshaft fastens to the clutch or transmission. TDC, or top dead center, refers to the piston at its uppermost position. BDC, or bottom dead center, refers to the piston at its lowermost position. These terms will be useful when we study other topics relating to engine operation. The cylinder head is a form of a lid or cap that bolts to the top of the block. The cylinder head and its related parts control the flow in and out of the cylinders or combustion chambers of an engine. There are several basic parts that fit into a cylinder head. The engine valve opens and closes the seat and port to the combustion chamber. The valve seat allows the valve to close and seal off the top of the engine. The valve port is a passage in and out of the engine. The cylinder head intake port allows the air and fuel to flow into the combustion chamber. As the injector fires, the fuel mixes with the air before flowing into the combustion chamber past the open intake valve. With direct fuel injection, only air flows through the intake port. The engine's intake manifold feeds air into the cylinder head port. The cylinder head exhaust port carries burned gases out of the engine. As they leave the exhaust port, they enter the exhaust manifold. The valve slides open and closed inside a valve guide, which is a sleeve around the stem of the valve. The valves must operate in tremendous high temperatures caused by the burning fuel. For example, as the exhaust valve opens, super-hot gases flow over the valve and seat and out into the exhaust system. A valve spring is used to close the valve and hold it secure on the valve seat. There are two types of valves used in the engine. One is the intake valve, and the other is the exhaust valve. The intake valve is normally larger than the exhaust valve. The valve spring fits over the valve stem. A retainer fits on top of the valve spring. The retainer works with the keepers to secure the valve spring to the valve stem. Note how the keepers fit into a groove machined in the valve stem. When the retainer is slid up, it locks the spring onto the valve. A tapered surface inside the retainer pushes the keepers inward to lock them in place securely. A head gasket fits between the cylinder head and the block. It prevents leakage of combustion pressure, oil, and coolant. The valve cover, also called the rocker cover, is a thin metal or plastic cover over the top of the cylinder head. It simply keeps valve train oil spray from leaking out of the engine. A camshaft is used to open the valves. On this engine, a cam follower fits between the valve and the camshaft. The valve spring pushes the valve closed whenever the camshaft rotates away from the follower. During actual engine operation, the camshaft would be rotating much more quickly. A cutaway view shows how the camshaft mounts on the top of this cylinder head. Some engines use one camshaft. Some can use 4 camshafts, as in this high-performance engine. The camshaft is mounted in either the cylinder block or in the cylinder head on cam journals. The cam journals ride on cam bearings, similar to rod and main bearings. The cam lobes are machined egg-shaped so that they can act upon the valves or valve train. For an engine to run properly, the cams must be timed with the crankshaft. Normally, the cam rotates at 1/2 crankshaft speed. Gears, a chain, or a timing belt are used to drive the camshaft or camshafts. The 4-stroke cycle needs 4 piston movements to complete one series of events. The intake stroke begins the cycle, and then comes the compression stroke, the power stroke, and finally the exhaust stroke. The intake stroke draws the air-fuel mixture into the engine's combustion chamber. The piston slides down while the intake valve is open and the exhaust valve is closed. This produces a vacuum, low-pressure area, in the cylinder. Atmospheric pressure, outside air pressure, can then force air and fuel into the combustion chamber. The compression stroke prepares the air-fuel mixture for combustion. With both valves closed, the piston slides upward and compresses the trapped air-fuel mixture. The power stroke produces the energy to operate the engine. With both valves still closed, the spark plug arcs and ignites the compressed air-fuel mixture. The burning fuel expands and develops pressure in the combustion chamber and on the top of the piston. This pushes the piston down with enough force to keep the crankshaft spinning until the next power stroke. The exhaust stroke removes the burned gases from the combustion chamber. During this stroke, the piston slides up while the exhaust valve is open and the intake valve is closed. The burned fuel mixture is pushed out of the engine and into the exhaust system. The crankshaft must rotate 2 complete revolutions to complete the 4-stroke cycle. With the engine running, these strokes happen very rapidly. At highway speeds, an engine runs at about 3,000 RPM, or 3,000 revolutions per minute. Unlike the basic 1-cylinder engine just discussed, Automotive engines are multi-cylinder engines, which means they have more than one piston and cylinder. Vehicles commonly have 4, 6, 8, 10, or 12-cylinder engines. A 4-cylinder engine is the most fuel efficient because it has less moving parts and internal friction. Additional cylinders smooth engine operation because there is less time, degrees of crankshaft rotation, between power strokes, and they generally also increase power output. You should now have a basic understanding of how an internal combustion piston engine operates.